In this video, we are going to review 5 questions that cover target 2A. We're going to start with questions number 1, 2, and 3, move on to question number 4, and finish up with question number 5. So let's get back to question number 1. Here's our function right here, and we'll want to figure out what the domain is. We're also given the graph right here already. So to explain domain, I want to refer to a graph that I did on Desmos. It's called, the website's called desmos.com if you've never used it before. And I want to point out that our parabola here is really just made up of tons and tons and tons of points all together. So if I put my pointer here and move this point from left to right, you'll see that our x values keep increasing. So right now we're at 3.8, now we're at 3.9, 4.0. If we move to our left, we get lower. So right here we're at 2.1. We move even lower, we're at negative 1.3. As we move higher, it'll be negative 2. So it's just tons and tons of points. But back to my domain. Our domain is going to be, we want to call out our lowest possible x value. And that means that if we go all the way to our left, we realize that it's not going to stop. It'll keep getting more and more negative. So we can say it approaches negative infinity. And we also want to figure out what our highest possible x value is. So as I get my point back up here, I see that I have x equals 1. Here I have x equals 2, x equals 3, and it's going to keep getting higher and higher. My x values won't stop. So that goes towards positive infinity. So my lowest x value was negative infinity. My highest possible x value approaches positive infinity. And we want to write this in interval notation, so whenever we see infinity symbols, we're going to use parentheses to enclose that on the left side and on the right side. So that's going to be domain. Question number 2 wants us to state the range, and range is really similar to domain, but range is going to be all of our possible y values. So I'm going to go back to my graph here, and I want to focus on all my y values. Right here I see that my y value is 4.9. And I want to look for my lowest possible y value. So if I move my cursor down here, now I'm at about 3.3. If I move it lower, I'm at 2, and then I'm at 1.8 here. I move lower, I'm at negative 0.68. I lower, lower, and lower. So I'm going to look at my lowest point here, and it looks like we're at about, yeah, there we go. It's negative 6.25. That's my lowest possible y value on this graph. So now we have our lowest possible y value. If we move our point all the way up here, we move higher and higher and higher, you can see that the y values are increasing. It's at 4, now it's at 5, it's at 6. So I'm going to go back to my paper here, and I'm going to write my lowest x value is negative 6.25, and then my highest is going to be infinity. And it's not really a value, I guess, but it's just we know that we don't have like a topping point. So we use parentheses with our infinity symbol, and because negative 6.25 is a part of my range, I'm going to use brackets so that we know we want to include it. Question 3 is just asking for our x-intercepts, and all that means is we want to figure out where our graph here intercepts the x-axis. So if we look closely, right here is where it intercepts the axis. This is where it intercepts the x-axis. So that point is going to be negative 2, 0. And then it also intercepts the x-axis at x equals 3. So that point is going to be 3, 0. And those are going to be my 2 x-intercepts. Remember, x-intercepts are just anything that intercepts my x-axis right here. Question number 4 is asking us to create a graph of this function. We also have to label the maximum or minimum as well as any x-intercepts. So you could do one thing here. You could graph this using your Inspire calculator, and then when you graph it, hit Control T or bring up your table and graph a bunch of the points on this coordinate system to help you. But I'm going to use Desmos again, and I graph this function already, and I'm just going to call out the points here by moving my cursor over what I need. So the first question, or the first part of this question, was asking us to find a maximum or minimum value. So remember, a maximum or minimum value refers to my y-coordinate, and in this particular graph, we don't have a maximum y-coordinate. If we move our point all the way up here, it just gets higher and higher and higher. So we know that we have a lowest possible y value, and that's going to be right here. That's going to be y equals -4. So that's going to actually be where my minimum is, and my minimum will actually be y equals 4. It's not the actual point, it's just the y value. The point is where that minimum happens. And then we also had to figure out what my x-intercepts were, and that is where my graph intercepts the x-axis. So those are going to be my two x-intercepts, -1, 0 and 3, 0. So let's go back just to make sure I answered everything. I figured out my max or minimum, and it was a minimum, and then my x-intercepts were labeled too. So on to question number 5. Question 5 has 3 parts. Part A is asking us to figure out the sign of the leading coefficient of this function right here. So we have a parabola that's upside down. Now I'm going to go back to my previous problem. I'm going to pull up my Desmos graph here, and I'm going to look at, well, let's see. Question number 5 has 3 parts, and part A is asking us to figure out what the sign of the leading coefficient would be for this particular graph function. Now I'm gonna use the function that we used in question number 4 to kind of demo this whole idea here. So when we had this function, we were given this graph right here, and if I change the leading coefficient here, so the sign of the leading coefficient, which is the number in front of my x squared, I'm going to change that to negative, and let's see what happens to the graph. When it becomes negative, it looks like my parabola flipped over. It wasn't a U anymore, now it's an arc. And if I take away the negative sign and I make it a positive, it looks like it goes back to being a U. So it seems as if I ever have a negative in front of my leading coefficient, in front of my quadratic term right here, it ends up being flipped and it looks more like an arc. So back to my question. This one is an arc, so it looks like the sign of my leading coefficient is going to have to be negative. Part B is asking us for the interval of the domain where the function is increasing. So we want to figure out where the y values are all going higher and higher and higher. So that's going to be right here on the graph. So I'm going to highlight this. All these values right here, they're the y values, they're all increasing. So what interval is that going to be on the domain? So that's referring to the x values. So it looks like this arrow is going downwards. So all my x values are going towards negative infinity. Just like question number 1, we know that they keep going on forever in the negative direction. And then as we move to my right, I move all the way to my right, all my y values are increasing until we get to this point right here. Then they turn around, they flip, there's a turning point there, and they start going down. So that's where they stop increasing, and that value for x is 3. I'm going to include that in my interval, so I use brackets, and then I'm going to use parentheses with my infinity symbol because that's what you always use with infinity symbols. Part C is asking for my interval or domain where my function is decreasing. So we want to look to where our y values are going down, and we recall that x equals 3 where there was a turning point. So all my y values are decreasing here, and it's going to go on forever. So the starting x value in my interval is going to be 3. So from 3 on to my x values keep increasing towards positive infinity there, that's going to be my interval. And then I'm going to use a bracket because we're including this x value for 3, and then we're going to use parentheses with my infinity symbol. So to recall the questions that we did, we started with 1, 2, and 3. It used this function. We moved on to question number 4, and then we finished up with this question number 5. And going back to that website, Desmos, DESMOS.com, it's a great site to use to figure out the domain and range and really to understand that concept.